Section 5 of Chapter 5 is long enough that we're going to split into two parts. And so we're going to start by dividing polynomials. And dividing polynomials is not necessarily difficult, but it is time consuming. So we'll just have 3 examples today and then I'll let you loose on them. The first step when you divide polynomials, the first thing is to remember you have to have every type of term, every value, every degree of the term of the terms shown in your divisor. So in this case, you'll see that I didn't have an x squared term, so you need to put a placeholder. Just like you do in regular division, you can't just leave out the tens place. You have to have a 0 in that tens place. If you don't have an x squared term, you have to have a 0 to fill that spot when you're dividing. So that's step 1. Once you've got your problem written out, then it's just a matter of dividing. And just like with regular division, you're looking at the first terms. So how many times will x squared go into 3x to the 4th? So what do you multiply by x squared to get 3x to the 4th? Well, you're going to multiply 3x squared times x squared. And so you're going to put that above the x squared term in your quotient. So 3x squared times x squared is 3x to the 4th, and that's what you want. So then once you want that first term to drop out and disappear. So when you finish that, then you still have to multiply this number by every other part of your divisor. So 3x squared times negative 3x is going to be negative 9x cubed. And if you've filled in every term, then this should just line up and you should be able to subtract just like you would with the place values. 5 times 3x squared is 15x squared. And then what you're going to do is you're going to subtract. And remember, when we're subtracting, you've got to change the signs on all of them. So when you're subtracting, what I do, just so that we're keeping positives and negatives straight, is I go ahead and I change the symbol on all of those terms within that polynomial, and then I just add. So this drops out, which is what you wanted to happen, and this becomes 4x cubed, and this becomes negative 15x squared, and then you can bring down, just like you do with regular division, divide, multiply, subtract, bring down. And now x squared times what is 4x cubed? Well, it needs a 4 and it needs another x, so plus 4x above the x terms. So then you have 4x cubed, and then 4x times negative 3x is negative 12x squared, and 5 times 4x is plus 20x. And then you're going to subtract, so change all the signs. This one drops out, which is what you want. This one leaves you with negative 3x squared minus 16x. Bring down the negative 6. And now same thing. You need to multiply by negative 3. So now you end up with negative 3x squared plus 9x minus 15. So change your signs. This one drops out. Negative and a negative, you add them. So you have negative 19, 20, 22, 24, 25 x plus 9. And so now, because you can't take something times an x squared and get an x, this becomes your remainder. And so just like with division, you're going to change that remainder into a fraction. And of course, there's no room in my area. So what you're going to do is plus, and then this would go out by the side of that. It's going to be, oh, and you can't see above there. Oh my goodness. It's going to be negative 25x plus 9 over your divisor, x squared minus 3x plus 5. So all of this, oh, this is really funny, is your answer. How's that? All right, pause it and do this next one. This one is actually a little bit easier because you just have two terms in your, it's just a binomial instead of a trinomial that you're dividing by. Do it on your own and then come back. And here we are back, and you already did it and got an answer, right? I hope so. All right, here we go. I'm going to make sure that I got that one right before I keep going, because that would be really embarrassing. Yay! Okay, so now you should have gotten 3x squared here, because 3x squared times x is 3x cubed plus 9x squared, and you subtract. Those go away. So here you've got what? 7, 8. 8x squared plus 21x. So now you need an 8x to make 8x squared. So plus 8x. So now you've got 8x squared plus 24x. Subtract both. Negative 3x, bring down your minus 11. And you're going to multiply by negative x, because that's going to give you negative 3x minus 3. Subtract, so change your signs. 8, negative 8. So then your answer is going to have a remainder of negative 8, so you'd say plus negative 8 over x plus 3. Or you can say minus 8 over x plus 3. Either of those is correct. All right? So now that was long division, and you might be saying, oh, there's got to be an easier way, and I'm going to tell you that I did something wrong. Oh, look, I did. 3. Yeah, I did. Check this out. Okay, so yeah, that's not an x. That needs to be a 3. Check that out. And you knew that, didn't you? Haha, you're saying, what are you doing? Negative 3 times x is our negative 3x, and then 3 times 3, this is 9, not 3. So this becomes negative 2, which makes this negative 2. And hopefully, if you did that on your own, you already knew that, and you're saying, well, duh. So there you go, fixed. All right, that's why I did it ahead of time, so that I could check and make sure. All right, so now you're saying, oh, there's got to be an easier way, and I'm saying, yes, there is. Just like we did synthetic substitution before, we can do synthetic division. So that was long division, and in regular dividing just real numbers, that's just really all you can do. But with polynomials, we're going to use synthetic division to divide this problem. So I want the two polynomials, 2x cubed plus 9x squared plus 14x plus 5 divided by the binomial x minus 3. Synthetic division, you need to know, will only work if you have just a binomial with one variable. All right? So you've got to have just one variable with the coefficient of 1. It needs to be like an x, I think they call it x plus k. It needs to be in the form of just an x plus or minus a number. All right, so if you're dividing by a binomial with no coefficient, then you can use synthetic division. Just like with synthetic substitution, you're just going to use the coefficients of each of those terms. So you're going to use the 2 and the 9 and the 14 and the 5. And you've got to make sure that you've got each term represented, and we do. And you're going to have an upside down division problem. And you're going to divide by the opposite of this. So you're going to divide by a positive 3. All right? And the reason you're doing that is because of the subtraction that happens along the way. So just like with synthetic substitution, you bring down your 2, and now you multiply. 2 times 3 is 6. Add those together and you get 15. 3 times 15 is 45. Bring those down, we get 40, 59. And multiply 3 times 59 is a bigger number. That's one that I did before, 177. And then add those together to get 182. So the way you translate this answer now is, you've got all the parts. These numbers now represent the coefficients of your quotient. All right, so these are the coefficients of your quotient. So your answer becomes, we started out with, this was x cubed. So we start out with 2x squared plus 15x plus 59. So do you see where these came from? This was an x cubed, so we're going to be 1 degree less than that when we begin. So 2x squared plus 15x plus 59 plus 182 over x minus 3. And that is synthetic division. All right, we'll do some more with that tomorrow. For now, it's just a lot of division. Have fun.